Hello friends, in this video I will discuss about amines chapter. So let us start. So these amines are considered as derivatives of ammonia. We know that ammonia, its formula is NH3. So amines, if we replace one hydrogen with some other organic compounds, so then we're going to get the amines. So like this. So if we replace it with benzene, then it is called as aniline. So like that, here we have this toluidine, orthotoluidine. So let us consider the preparation of amines. So if we need to consider the nitrobenzene, if we reduce it with the help of hydrogen, palladium, nickel, platinum, presence of ethanol, or we can consider the other type of reduction methods. So tin HCl or iron HCl, here we are going to get the aniline, right, like this. So we'll consider the reactions of this amines. So this amines, they acts as base. So for that reason, in presence of this haloalkanes, so they're going to give some type of salt. So that we'll consider. So this aniline or this ammonia, it acts as a nucleophile, right? So here we're going to get the substituted ammonium salts. So you can consider this one nucleophile plus. So it's going to attack on this R. Here we're going to get the RNH3 plus X minus substituted ammonium salt. Now we're going to consider the Gabriel thalamide synthesis. So first we're going to consider this one. So this is the thalamide. So this is thalamide. So in presence of this KOH, here we're going to get the salt. So because this is base, so this is also base, here we're going to get the salt, right? So N minus K plus. So in presence of this RX, here we're going to get the NR. So if we put it into water, here we're going to get the primary amine, RNH2. So this whole process is known as Gabriel thalamide synthesis. So actually there is a reaction between KOH and NH, because so even though both are base, but their basic nature is different. So one is more strong and second one is less strong. So for that reason, here we're going to get here we can expect some salt. So after that RX, here we're going to get the substituted amide. So once we put it into water, here we're going to get the primary amine. So let us consider the next type of reaction. It is known as carbylamine reaction or isocyanide test. So RNH2 in presence of CH3Cl in presence of KOH, if we heat it, here we're going to get the isocyanide RN triple bond C. So this one is a foul smell. So this is the confirmation for amine, presence of amine. So then we'll consider the electrophilic substitution reaction. So this is one type of typical reaction that we'll consider. If we take this aniline and put it in presence of acetic anhydride, CH3CO twice O, acetic anhydride, here we're going to get the acetamide, NHCOCH3, benzene with this acetamide, benzene acetamide. So if we consider the bromination, that is the bromine acetic acid, so this bromination takes place at para position. So if we do hydrolysis, so we can able to get the para-bromo aniline, right? So then we'll consider the diazonium salts. So diazonium salts. So this aniline in presence of sodium nitrite and HCl, here we're going to get the diazonium salt, that is NaNO2 plus HCl at 0 to 0 degree Celsius. C6H5N double bond N plus Cl minus. So this is diazonium salt. So if we use a different reagent, here we're going to get the different products. Cu2Cl2 in presence of HCl, here we're going to get benzene with chlorine or chlorobenzene. Cu2Br2 HBr, here we're going to get the bromobenzene. Like that, CuCN bar KCN, here we're going to get the benzene with CN. So like that, copper HCl, again we're going to get ARCl copper HBr, again we are going to get the ArBr. So like that Ki, here we are going to get the benzene iodine, iodobenzene. So like that fluoroboric acid HbF4, at that time we are going to get ArF. So like that H3PO4 H2O, here we are going to get the ArH, that is the benzene itself. If we add H2O to this diazonium salt, here we are going to get the ArOH, that is phenol. So like that we are going to consider the coupling reaction. So in this one, so we need to take this diazonium salt, again we need to add this phenol. At that time here we are going to get the benzene double bond N OH. So this product is a dye, it is known as orange dye. So this one is known as coupling reaction, right? So in this chapter we will consider the aldehydes, ketones and carboxylic acid chapter. So you can see this one, R C double bond OH, then it is aldehyde, R C double bond OR, then it is ketone, R C double bond OH, then it is carboxylic acid, like that R C double bond O, so then it is X. So this halogen is attached to C double bond O group, so for that reason it is called as acyl halide. So like that, if we remove one water molecule from carboxylic acid group, at that time here we are going to get R C double bond O C double bond O R dash. So this product is known as acyl anhydride. So we'll consider the preparation of aldehydes first. So this is Rosenmund reduction, that is acyl chloride. So first we will consider the benzene acyl chloride. So to this one, if we do the hydrogenation in presence of palladium BaSO4, so at that time it will undergo only one step reduction to give the C double bond OH, right? So like that. So we can do the same thing for one more step, RCN. So in this case, if we use diisobutyl aluminum hydride, so at that time here we going to, it will undergo only one step reduction to give RCHO, right? So here in this case, so CrO2 Cl2, this is known as chromyl chloride. So we'll consider next one, that is Friedel-Crafts acylation. So through Friedel-Crafts acylation also we can able to prepare the aldehydes. So first we need to take the benzene, so then acyl chloride RC double bond O Cl. So in presence of anhydrous Cl3, so here we are going to get benzene acyl chloride. So here we are going to get the ketone, right? So let us consider the next reaction. So that is aldol condensation reaction. So this aldol condensation reaction are specific for aldehydes and ketones. So this aldehydes and ketones with at least one alpha hydrogen in dilute alkali gives aldol, right? So this particular reaction is known as aldol condensation. So let us consider this one. So if you see this one, so this carbon, the one carbon which is next to CHO is known as alpha carbon. So this alpha carbon has 3 hydrogens. So in presence of or in dilute NaOH, so it will gives, so one of the CHO is get reduced to give one step less product, that is, so this aldehyde to alcohol. So at that time here we are going to get this type of compound, right? So this is known as aldol, CH3 CH2OH CH2 CHO. So if we heat it, so there is a loss of one water molecule, then we are going to get, so this aldol. So this is aldol condensation product, CH3 CH double bond CH CHO. This is aldol condensation product. So then we will consider next same aldol condensation. So instead of this alcohol or this NaOH, we can use some different bases also, CH3 COCH3. So this is ketone. So BaOH twice, CH3 CCH3OH CH2COCH3. So if we do the condensation, that is the removal of one water molecule, at that time CH3 CCH CH3 double bond CH CO CH3. This is aldol condensation product. So then we will consider the cross aldol condensation. So here in this case, one is CHO and second one is ketone. So in presence of OH minus or in presence of base, here we are going to get CH double bond CHCO. So this benzene. So this is benzyl acetophenone, right? So then we'll consider the Cannizzaro reaction. So instead of that weak base, if we use strong base at that time, so this and also if there is no alpha hydrogen at that time, so these ketones undergoes disproportion reaction, that is both oxidation and reduction reaction to give this alcohol and next product, that is carboxylic acid. So we'll consider this one, formaldehyde HCOH, and again one more formaldehyde. So one formaldehyde and again one more formaldehyde in presence of concentrated KOH. So if we heat it, we're going to get methanol plus potassium formate. So here we can consider, so if we use this benzaldehyde in presence of concentrated NaOH, here we are going to get benzyl alcohol plus sodium salt of benzoic acid. So we'll consider next one, that is reactions of carboxylic acid. So this carboxylic acid undergoes this dehydration reaction to give anhydrides. So CH3COOH. So in presence of H plus or P2O5, if we heat it, so here we are going to get CH3COOCH3, right? So this is anhydride. So again this carboxylic acid reacts with PCl3, PCl5 and SOCl2 to give so corresponding that acid chlorides, right? So CrCOOH plus PCl5, RCOCl, POCl3, like that PCl3, RCOCl, like that SOCl2, RCOCl, SO2. So then we'll consider this one, reaction with ammonia. So this carboxylic acid react with this aniline or this ammonia to give benzene COO minus NH4 plus. So if we again heat it, so there is a loss of water molecule to give benzamide, that is benzene ring with CONH2. So like that, if we have two carboxylic acid groups attached to ortho and next group, ortho and meta positions at that time, so this carboxylic acid plus NH3. So here we are going to get so first it's salt, then we reduce it, so heat it strongly, then here we are going to get thalamide, right? So that is CONH2CO. This is thalamide, right? So this is all about this chapter. So remaining things we are going to discuss in our next class or next chapter.